Hello po, Miss, nakamute po ata kayo.
Now for the torque, we have the moment of force, effectiveness of the force to produce rotational motion. Now the torque is the product of the force and the moment arm, where L is equal to F times S. Now, for the second condition of equilibrium, the vector sum of the torques acting on a body is 0. Equilibrium of rigid body, parallel coplanar forces. The moment of a force or torque about an axis is the effectiveness of the force in producing rotation about the axis. It is measured by the product of the force, perpendicular distance from the axis of rotation to the line of action of the force, where moment is equal to force multiplied by the perpendicular distance from axis to action line of force. Okay, a body is in transitional equilibrium if it is at rest or is moving at constant speed in a straight line. It is a rotational equilibrium if it is not rotating at constant angular speed about an axis. A system of force acting on a body produces equilibrium if when acting together, the forces have no tendency to produce a change in the body's translator or straight line motion or its rotary motion. Now, what are the conditions of equilibrium under action of parallel coplanar forces? Now, for the conditions of equilibrium under action of parallel coplanar forces, number 1, the algebraic sum of the forces acting on the body in any given direction must be 0. Number 2, the algebraic sum of the moments of all the forces acting about any axis perpendicular to plane of the forces must be 0. This one is from the book of Physics 1 Workbook and Study Guide by Lugo and Luna. Okay, then we have a couple consists of two equal and oppositely directed parallel forces, not in the same straight line. A couple can produce only rotation. Then the moment of the couple is equal to the product of one of the forces and perpendicular distance between them. A couple can be balanced only by another couple or equal moment in the opposite direction. When you say couple, the same magnitude but lying on the opposite direction. Okay, example is this one. Okay, when you say couple, okay, 10 newtons and then 10 newtons. This one is a couple. The same magnitude but lying on the opposite direction. Okay. Then the center of gravity of a body is the point at which the entire weight of the body may be considered as concentrated. The line of action of weight passes through the center of gravity. A single vertically upward force equal to the weight of the body and applied at the center of gravity will keep the body in equilibrium. Now, for the equilibrium of rigid body, non-parallel coplanar forces, what are the conditions of equilibrium? The equilibrium of a body under the action of a non-parallel force acting in a plane can be reduced to a problem in two sets of parallel forces by considering horizontal and vertical components. Okay, then the two conditions of equilibrium then become number 1, forces. The vector sum of all forces acting on a body is equal to 0. This is equivalent to saying that the algebraic sum of the forces or component of forces acting on a body in any direction is 0. That's why we have the summation of forces at x is equal to 0. That is because of the equilibrium. And we have the summation of forces at y, which is also equal to 0. Okay. Then the moments, the algebraic sum of the moments of all the forces about any axis perpendicular to the plane of the forces is equal to 0. Okay. Summation of forces at x equal to 0. Summation of forces at y is equal to 0. And the summation of moment is equal to 0. Now, for the special For the special case equilibrium under action of three non-coplanar forces, the three forces must lie in a plane. Their lines of action must intersect in a common point. The vectors representing them can be arranged to form a closed triangle with sides respectively parallel to the direction and proportional in length to the magnitude of forces. Example number 1. With a light horizontal bar is 5.0 meter long, a 2.0 Newton force, a 2.0 Newton force acts vertically upward on it 2 meters from the right hand end. Find the torque about each end. Okay, from the given, we have this one is the left, right. We connect horizontal bars 3 meters long, 5 meters. A 2.0 Newton force acts vertically upward on each 2 meter from the right. Therefore, we have 2.0 newtons, 2 meters from the right, 3 meters long. Then, find the torque about each end. Okay, the torque at left is equal to S times F or F times S, which is equal to, from left, therefore we have 3 meters. 3 meters times 2 newtons is equal to 6 meter Newton. Okay, therefore, the direction of your force is going upward. If you're going to the left, therefore that is counterclockwise. Counterclockwise. Now, for the torque at the right, is equal to S times F. Therefore, that is 2 meters. 2 meters. 2. 1. We have 2 meters times 2 newtons, which is equal to 2 times 2 is 4 meter Newton, clockwise direction. Okay, for number 2. Okay, number 2. Take a rope, smooth, round a shaft, 15.0 centimeter in diameter. If a pull of 500 newtons is exerted on the rope, what torque is imparted to the shaft? The shaft. Have 500 newtons, diameter 15 centimeter. Torque is equal to S times F, which is the radius kasi sa gitna. A rope is wound around a shaft. The diameter of a pull of pipe is exerted. What is the torque imparted to the shaft? 15 divided by 2 is 7.5 centimeter. 7.5 centimeter times 1 meter over 100 centimeters times 500 newtons. Therefore, the torque is 37.5 meter newton. Last problem. Number 3. A bar 3 meters long makes an angle of 25 degrees with the horizontal. A vertical force of 15 newtons is applied. 0.4 meter from the upper end. Calculate the torque due to this force about each end. Okay, 2 meters long. Once we have 25 degrees. 25 degrees with the horizontal vertical force of 15 Newton is applied 0.4 meters. Okay. 15 newtons. 15 newtons. 50 newtons, correction. 50 newtons. 50 newtons. This one is 50 newtons. 0.4 meters from the upper end. Therefore, this one is 0.4 meter. If this one is 0.4, the total is 3 meter. Therefore, this one is 2.6 meters. Okay, therefore, we have okay, therefore, this one is your y. Put this one as your y. This one is your y. And this one is your x. X. Okay. If this one is 25 degrees, of course, this one is also 25 degrees. Okay, let us find this first. 25 degrees. Cosine 25 degrees is equal to y over 0.4, where y is equal to 0.4 cosine 25 degrees. Okay, 0.4, and therefore this one is 0.363 meters. Okay, that is the value of your y. Okay, let this one as your a, and this one is your b. Now, for the moment at b, we need okay, the reason why we get the value of your y because that it would be your perpendicular distance for your 50 newtons. Therefore, we have y times x, where y is 0.363 meter times 50 newtons. Okay, therefore, the torque at B is equal to 0.363 times 50 is equal to 18.15. 18.15. Therefore, that is clockwise. Meter Newton, clockwise direction. Now for torque at A, first get the value of Rx. Cosine 25 degrees is equal to x over 2.6, where x is equal to 2.6 times cosine 25 degrees. Therefore, that is 2.36 meters. Okay, torque at A is equal to 2.36 meter times 50 newtons, which is equal to 118 meter newton counterclockwise. Okay, counterclockwise direction.